All right, welcome back. Question 8, here we go. Find a polynomial p of degree 3 with integer coefficients that has zeros 3 and 2 minus 5i. It only has degree 3. I should have given you guys degree 5. I know you're probably disappointed about that. Not. So the first 0 is 3. We're going to write all these in factored form. So if you have 3, your factored form is x minus 3. Remember, we talked about if it's a binomial, what do we need? Brackets. So remember, hashtag brackets for binomials. So I am always going to start these with x minus. Usually students will forget to do the x minus because the binomial already has a few terms in it, but you have to have x minus. Remember, every factored form is going to be x minus c. So when you have a binomial, it has to be minus because you're going to be distributing that negative. So when I do that, I have x minus 2 plus 5i, x minus 2 minus 5i, and then remember I'm going to group the real parts together, and this is going to be helpful so that when I FOIL in my next step, I'm going to be multiplying x minus 2 times itself. So when I FOIL, my first term is x minus 2 times x minus 2, which is x minus 2 squared. We know that because these are conjugates, the middle are going to cancel out when we multiply and add those together. And then 5i times negative 5i is negative 25i squared. Now, another common thing people will do accidentally is they'll forget that they have to just add this and they'll accidentally multiply. So keep everything inside your bracket because we're going to combine like terms before we distribute the x minus 3. So when we go ahead and FOIL this, okay, x squared minus 4x plus 4. Okay, this is not x squared minus 4. You have to FOIL x minus 2 times x minus 2, x squared minus 4x plus 4. If we plug in negative 1, negative 25 times negative 1 is positive 25. So then I'm going to add 4 and 25 together, which is going to give me x squared minus 4x plus 29. And all of that's multiplied by x minus 3. So what I like to do is I like to distribute the x first, which will give me x cubed minus 4x squared plus 29x. Then I'll distribute my negative 3. And when I do that, I'm going to line up my like terms. So I get negative 3x squared, and then I get positive 12x. Negative 3 times 29 will be negative 87. And now I can just add my like terms straight down. When I do that, I'll get my polynomial p of x equals x cubed minus 7x squared plus 41x minus 87. So your polynomial is p, so it should have p of x equals, and then the rest of your polynomial equation. All right, for number 9, we're going to find all zeros of the polynomial and state the multiplicity of the zeros. So if they occur more than once, we're going to state that. If the multiplicity is 1, then you don't need to write that part down. Okay, so this is really similar to finding the zeros that we did on the first page. What we're going to do is find the possible zeros first. Okay, so from p over q, so factors of 12 over 2. So factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now when I divide those by 1, that's how I'm generating this list here. When I divide by 2, if I do 1 divided by 2, I have 1/2. 2 divided by 2 is 1, so I already have that. 3 over 2, I'm going to keep that. 4 over 2 is 2, I already have it. 6 divided by 2 is 3, I already have that on my list. And 12 divided by 2 is 6, and I already have that on my list. Okay, so that's going to be helpful when I go to my graph. Now, when I go to my graph, the only zero I can see is at negative 1.5. or negative 3 over 2, which I know because it's on my list. So I'm going to verify that with synthetic division. And the reason why I want to do that is so that I can take this quadratic equation that's formed here and use the quadratic formula to find the zeros that are not on the graph. So when I write this out, I have 2x squared plus 4x plus 8. You can go ahead and plug this into the equation how it is, or if you notice that 2 goes into all of them, you can divide by 2, and that's going to make your simplifying easier. So if you didn't divide by 2, I'm going to go over that with you. You'd have the opposite of 4 plus or minus 16 minus 4 times 2 times 8 over 2 times 2. When you simplify under the radical, you're going to have negative 48. And I'm going to bring the I out first because it's a negative. And then the perfect square in 48, the biggest one is going to be 16. So I'm going to simplify this radical to 4i root 3. So I have negative 4 plus or minus 4i root 3 over 4. And then remember, I have to divide both of these by 4 in order to simplify. So negative 4 over 4 is negative 1. 4i root 3 divided by 4 is going to be I root 3. So negative 1 plus or minus I root 3 is going to be my final answer. Okay, so for my zeros, it's negative 3 over 2, and then negative 1 plus or minus I root 3. My total number of zeros for this is 3 because it's the same as the degree, which is according to the fundamental theorem of algebra, which we have talked about. So there aren't any multiplicities here, and that's fine. All right, and then for B, we're doing the same thing. I have a longer polynomial equation here. X to the 5th minus 3x to the 4th plus 28x cubed minus 76x squared plus 75x minus 25. So again, I'm going to think of all of my possible rational zeros, which for this one, because I have 1, my possible rational zeros are just going to be the factors of 25. Okay, so if I want to write those out, I will write them out here. So plus or minus 1, plus or minus 5, plus or minus 25. And then you can go to your graph, and I could see from my graph that it crossed at 1. So I'm going to do my first synthetic division. I'm also going to graph this on my graphing calculator so I can show you how something special is going to happen there when you have a multiplicity. And why I'm doing that, go ahead and check out my synthetic division. So you're going to bring this down. 1 times 1 is 1. Negative 2 times 1 is negative 2. Add straight down. Multiply across. Okay, multiply across. Add straight down. And then I get 0, which lets me know that this is a 0. So when you graph this, it may look like that 1 is the only 0, and that may be true. Your only real 0. Okay, this is a long equation. So here's my graph. The little bar there says it's doing its magic. Okay, and then remember I told you there were 2 cases where you could tell where you had a multiplicity. So one is if it touches and goes back, that's when you're going to have an even multiplicity. The other one is where it's going to bend as it crosses the x-axis. And I'm just going to zoom in there for you so you can see the bend a little bit more clearly. So it's bending as it's crossing the x-axis here, which means you're probably going to have a multiplicity. So once you see, oh my goodness, this is the only 0 that I have, okay, that means that you're going to try and do 1 again. Now, you aren't going to use the original coefficients because you want to get smaller equations and so that you can get a quadratic. So now I'm using the coefficients of the synthetic division that I just did, and I'm going to try 1 again. Okay, now I'm here. I have a cubic equation, but I want a quadratic, so I'm going to do 1 one more time. So when I do 1 one more time, I get x squared plus 25 equals 0, and you cannot factor this, okay? It's a positive. That special pattern is the difference of 2 squares, not when there's a sum. So you're going to subtract 25 over, and you can take the square root, so you'll get x equals plus or minus 5i. And some special cases here, you can factor when you have your cubic equation. And for this one, it looks like you would be able to factor. You could take out like this would be x cubed minus x squared plus 25x minus 25. And you would be able to factor that as well. And when you do, you would have x minus 1 multiplied by x squared plus 25. So here you get the plus or minus 5i when you solve that. And this other one that we found with synthetic division, you would get that by solving the x plus 1. Okay, but you don't have to do it like that. You can do synthetic division, or like I said, if you factored, wrote this as a cubic and factored, that would be fine too. So our zeros, we're going to have 1 with a multiplicity of 3 and then plus or minus 5i. There's 5 zeros total because the degree is 5. And you will need to know that and understand that for your test. The multiplicity of 3 means those are 3 zeros. The positive 5i is 1 0. The negative 5i is another. So that is going to give us a total of 5. All right. See you later. Bye.